Unlike F# and similar languages, C# does not support collection comparison for equality. All it does is compare them by reference. Was that decision correct? Yes, and it takes a little bit of thinking to understand why. In this demo, I will show you that there is no one answer to the question whether two collections are equal or not. There are multiple correct answers. And so, when the creators of C# had to make a decision, they could not decide which of the correct comparisons is correcter than the others. So they fell back to reference equality comparison. That's how C# works. Code is telling more than 1,000 words. Let me show you how that works. Here I have one list and I have another list, and those two lists are the same. I can use equals that is defined on every object, including lists, and that call will still return false in C#. That is because the lists are compared by reference and these two objects are obviously different by reference. However, the question is, should this be true? I will reverse the list and push it onto a stack. The sequence would be the same again. Equals will still return false, but the question is, should this be true now? Another list with the same values in it, but in a different order. Equals will say false, and again, should this be true? So what I have shown you here are three distinct cases. It's quite obvious that there are at least two ways to compare these collections, if not more. For that reason, we have the IEqualityComparer interface which we can implement. So we can create a class which represents the comparison we consider correct in code that we are writing now. Anyway, I don't want to compare objects of type T, I want to compare sequences. So this will be the comparer, the equality comparer of sequences. That will require some constraints. I don't want to deal with nullable elements. Also, I want the elements to be equatable, comparable for equality, because what I'm doing here is to lower the definition of sequence equality to the level of elements inside of them. I want to compare the elements and in that way to conclude whether two collections are equal. The IEqualityComparer interface defines two methods, equals and getHashCode, and so it's easy to implement equals. First I dismiss null sequences, and then comes the substance, because now I have to define what equality means for me. One possibility is to use the link sequence equal method, and in that way I have chosen the definition of equality. Two sequences, two collections, whatever they are equal in my view if they contain the same values in the same order. I don't care whether one is a list and another is a stack. I'm not checking the type of the collection. It could be a tree or whatever. I only check whether they serve the elements in the same order. That is one very specific definition of equality. Then comes the getHashCode. I will prepare a helper method that uses the hashcode object and adds one item to it. Now, hashcode is a very useful little class that will let you calculate very good hash codes. However, it is sensitive to the order in which you add elements to it. In other words, when you implement a getHashCode, you must add elements to the hashcode instance in the same order in which you are comparing them in the equals method. You must not scramble them. It's very important because then the sequences for which equals returns true will simultaneously return the same hash code values. And that is the requirement you must satisfy when implementing IEqualityComparer interface. So it's done. I will call this equality comparer the sequence comparer because that is what it does. It compares two sequences. And that is specific, just like a new comparer which I just planned to implement will be specific in a different way. It will be the content comparer. And since it is tricky, I will also request that the elements of the sequences implement IComparable because I plan to do a trick here. I will sort each of the sequences. The comparison of sorted sequences will be that sequence comparer I already have. And so, two sequences are equal when looking at their content if I can order one and order the other one, and if equals of the sorted comparer says the sequences are equal. I will have to order the sequence again before passing it to the sorted comparer which operates on sequences, because, as I said, the order in which hash code is calculated depends on the order of elements in the sequence, and that order must be the same one that is used in the equals method, or otherwise this class would be just incorrect. It would contain a bug. So I will now show you how these two comparers behave on these collections we have here, and you will see how that works. Before that, let me tell you that you can download this code and the source code from all other videos from my Patreon page. This video and all videos on my channel are free only thanks to the patrons, the people who support this channel. So, if you like what you have learned from this video, then please consider joining the community of patrons on my Patreon page and support this channel. Thank you very much. Now let's continue with the demo. I will create one comparer and the other comparer, and I will now choose the definition of equality that I want to apply in each particular scenario. So the two lists with the same content will be equal when the sequence comparer is used. But if I used the reordered list, the sequence comparer will tell they are not equal. On the other hand, if I wanted to still treat these two collections as equal, then I might use the content comparer, and it would definitely say that the two collections are equal despite the difference in the order of their elements. Again, it's your call, you tell what is equal. And now let's re-examine that decision of the creators of C# to fall back to reference equality. Here is one of the important aspects of any comparison: performance. In the early days of C# especially, C# was built to be fast. And so reference equality takes constant time. Just compared to references do nothing. But if you want to compare sequences, then it will take time proportional to the length of the sequence, O of n. And if you wanted to compare content with multiple values that are equal, which means it is a multiset, not a set, then it's even worse, n logarithm n. And the last question is the crucial one. Equality is not defined on mutable objects. I might say, oh, memory is expensive. Let's save some memory by throwing one of the two objects and using the other one in place of it. Is this code correct now? Oh, of course not. The two collections, even though the IEqualityComparer said are equal, they're anything but equal. They're completely different collections with different content. And worse yet, I could just come up and mutate one of the collections. The flag that they are the same, which is set to true, would lie to me. It should have been false after this change, but, well, the situation is that I missed the opportunity to capture that one of the collections was mutated, and now I'm completely wrong. So this particular code contains two bugs. It is wrong on two accounts. Between the lines, I don't think you will ever really want to know whether two collections are equal.